All right, so now I want to introduce the z-plane. And the way I'll get there is to talk about a sampled generalized complex sinusoid. So I'll define y of n as x of nt. So I'm just going to sample the generalized complex sinusoid, and there are various ways to write that. So I'll write it as the generalized, so we define x of t as a e to the st. So two complex points define this generalized complex sinusoid. And I have to now evaluate it at t equals nt. So that's mathematically how we sample a continuous time function. So now what does it become? It becomes, the amplitude just rides along. Nothing happens to the amplitude. It's just a complex coefficient. But the exponential becomes, the complex exponential becomes sampled. So it becomes as nt, and we can factor that as e to the st to the n. And so we'll call this little e to the st part z. And so we can say now we're defining this as the same complex amplitude times z to the n, where z is defined as e to the st. So this is one mapping from the s-plane to the z-plane. And it is used. But it's not the ideal one in practice because it aliases. It's ideal conceptually. So as the sampling rate goes to infinity, it's ideal. It's the one you want. For an infinite sampling rate, just use this. For a very, very high sampling rate, use this. Or for very low frequency analysis, you can think of this. All the others will reduce to this. Like even if you're using like the bilinear transform, as the sampling rate goes very high, if you scale things properly, it will look like this at low frequencies. So this is the one you really want, but the problem is it aliases. And does everybody know what I mean by aliasing? We'll just look at, I'll just say as a by the way, that e to the j omega plus any multiple, I'll use capital K as my integer multiple of, let me make this be omega t, put that in there. So now we have instantaneous phase there. So any multiple of 2 pi is indistinguishable. So this is just an example of aliasing. Maybe it's better to write it the other way. I can also write it as e to the j omega plus any multiple k of 2 pi over t. So because what is 2 pi over t? That's the sampling rate. That is omega sub s, which is 2 pi f sub s. That's our sampling rate in radians per second. And then, of course, k is an integer. So this aliases. That's what I mean by aliasing. So the way we really use this, though, is we make sure that our signals are band limited to plus or minus half the sampling rate, and then when we map to the z-plane, we don't have any aliasing. All the aliasing happens for components with 0 amplitude, we can say. All right, but still, this is the really natural mapping. And so now, what happens to our generalized complex sinusoids? Well, you see it right here. Let me just repeat it. Y of n equals complex amplitude times a point z in the complex plane to the nth power. So n is an integer, and complex amplitude is complex. So